Hi friends, in today's video lecture, we are going to see about limits. In the previous video lectures, we learned what is differentiation, how this differentiation is derived. So without the concept of limits, the differentiation does not exist. So today I am going to teach you what is the main application of the limits and I am going to solve some basic problems in limits. Okay. So the this we call as limit, okay. Limit x tends to a, limit x tends to a, we call this as a limit x tends to, this is okay, tends to a, f of x is equal to L. If for every positive number epsilon, however small, so there is a small epsilon and there exists a positive number delta such that modulus of f of x minus L is less than epsilon and 0 less than modulus of x minus a is less than delta. So it means that suppose there is a function, okay, and we know that if x is a point and f is a function, then it will mapping where you will get f of x is an element. Okay, so x is a point and a is a point, and suppose there is a distance between these two will be less than delta, and we can say this is the same limit f of a. We can say this f of a that is equal to L, and this is also exists, and this must be less than epsilon. So if it is less than epsilon, then there will be a delta which is less than the difference of x and a. Okay. So this is the left hand limit. We call this as left hand limit because negative sign in the x-axis, it is left hand side in the axis, and this is the right hand limit. Okay, right hand limit. So if this right hand limit and left hand limit both converge to a point, particular point, then we say that that is the limit point. So in general, what is a limit point? Suppose we are doing some process. Okay, suppose we are trying to reduce some production of a particular chemical, then at certain point we could not reduce the production. Okay, so this limit concept will help us to find a limit point, that means the maximum or minimum point at which the process can obtain the value which we are expecting. Okay, so I am going to teach you a small example. Application of limit. So let the typesetting cost rupees 10,000 for a book. So the manufacturer is fixing some cost for the typesetting of a book. Like typesetting of a book is nothing but that typing cost of the book. Okay. Let the cost of printing paper etc. be rupees 10 per copy. Suppose you want to get a copy, then it will be 100 rupees for printing and paper everything. For typing alone, it will be 10,000. Okay. Consider that no other cost is involved. So we are considering that there is no other cost. Find the minimum cost per copy. So what will be the minimum cost? We can get the book in the minimum cost. Okay. So that is what I am going to do. So in general, please think about this. If a typesetting a copy of typesetting cost for a book or something one time, it is a one time cost, right? So only one time we are paying the 10,000. After that we are not going to pay that. So if you are producing or else purchasing more number of books from the same manufacturers, then the cost will be reduced, right? If the manufacturer produce more number of books with the same typesetting cost, then the cost will be reduced. But how much it will reduce and what will be the minimum cost? That's what we are going to see. In general, we used to know that, no. So if we are purchasing 10,000 book, there the cost will be reduced and we are getting some amount of discount everything. So that the back end work is that there is a minimum cost per copy. That is what we are going to find. Okay. So I am going to explain with small cases. My case one. Case one. Suppose to prepare this one 1,000 copies. So what we are planning, we are producing 1,000 copies. Okay. So what will be the cost per copy? That's what we are going to find. So the cost, so we fix that rupees 100 per copy is constant. So we are getting 1000 copies and 100 per copy, and 10,000 typesetting cost is for a book. So we are purchasing the same book, so it will be 10,000. So total amount we are getting 1,10,000. This 10,000 is the typesetting cost. This 1 lakh because we are producing 10,000 copies. So cost will be like this. So what will be the cost per book? Okay. So cost per copy equal to this 1,10,000 divided by 1000 because we are producing 1000 copies, right? So the cost of a book is 110 rupees. So if we are producing 1000 copies of the same book, the the typesetting cost will be same, remaining same, that is 10,000, and we are producing 1000 copies. So we must sell the copy with 110 rupees minimum cost. Okay. Suppose I am producing 5,000 copies. Okay. Case 2. To prepare 5,000 copies, so the cost will be 5,000 into 100 plus 10,000. So it will be 5,10,000, and cost per copy equal to 5,10,000 divided by 5,000. So this will be 510 divided by 5. So it is 102, right? So if I am preparing another 4,000 copies in addition to that, my cost will be reduced, so I can sell the product without 102 rupees, right? Look at this. So we are going to check how much we can reduce more than this. Case 3. To prepare 1 lakh copies. Okay. So the cost will be 1 lakh copies into 100 rupees plus that typesetting cost, that is 10,000, will get 1,10,000 rupees. So the cost per copy will be 1,10,000 divided by 1 lakh, and this will get cancelled. Okay, so it will be 100.1. Even though you are increasing the preparation of 1 lakh copy and more than 1 crore, it will not get reduced below 100 because we fixed the cost per copy is 100 for the printing charge and everything, for the paper charge, everything. So that won't reduce. Okay. So the minimum cost of the book will be 100, and that how happen is the typesetting cost will be 0. Okay, if there is no typesetting cost, we can sell the product by 100 itself, right? So this is how we are finding the limit point. So with limit point means we cannot reduce the amount of this particular book lesser than this 100. Okay, we can fix the amount more than this 100. So this is how this limit point works. I am going to teach you some basic problems using this limits. Okay. Find limit x tends to 2 f of x when f of x is equal to x square plus 4 divided by x plus 2. So there are two methodologies to find the solution. So I am going to teach the first method one. Method 1 is very simple. You just substitute the x with 2. So limit x tends to 2, f of x is equal to limit x tends to 2, x square plus 4 divided by x plus 2. Replace your x with 2, so it will be 2 square plus 4 divided by 2 plus 2. 2 square is 4. 4 plus 4 divided by 2 plus 2. So 8 by 4, that is 2. Okay. Then method 2 is what is given in the definition. That means the process of left hand side and right hand side limit. Okay. To 2 minus f of x. That means the left hand side limit. Or else we can say that limit h tends to 0. Okay. F of 2 minus h. So we know that f of x is x square plus 4 divided by x plus 2. So f of 2 minus h will be 2 minus h the whole square provided your limit h tends to 0 plus 4 divided by 2 minus h plus 2. Right? So this will be limit h tends to 0. 2 square will be 4 plus h square minus 4h plus 4 divided by 2 plus 2 will be 4 minus h. Okay. If I am putting this h tends to 0, you will get this term and this term will be 0 and again this term will be 0. So 4 plus 4 will be 8 divided by 4, 2. Similarly, I am going to find the right hand limit 2 plus f of x, that is limit h tends to 0 f of h plus 2 or 2 plus h, which is equal to limit h tends to 0 2 plus h the whole square plus 4 divided by 2 minus h plus 2 plus h divided by 2, so which is equal to limit h tends to 0 4 plus h square plus 4h plus 4 divided by 4 plus h. When h tends to 0, this term will be 0, so it will be 8 by 4, that is equal to 2. So we know that the left hand limit and right hand limit both are tends to 2. So limit x tends to 2, your f of x will gives you 2. So this is the first methodology to find the solution and this is the second methodology to find the solution. We'll move to the next problem. So look at this problem. Find limit x tends to 2 f of x when f of x is equal to x square minus 4 divided by x plus 2. So it is in a similar manner we are going to solve this problem also. Okay. So solution. I am going to use the method 1. Okay. Method 1. So limit x tends to 2 f of x equal to limit x tends to 2 x square minus 4 by x plus 2. So when I put it will be 4 minus 4 divided by sorry, it is actually negative. 4 minus 4 divided by 2 minus 2. So this will be 0 by 0. We cannot find 0 by 0. Okay. So 0 by 0 is indeterminate form. So for this indeterminate form, what we are going to use? We are going to use three different methodology. So in case if you are substituting the limit value into the function and you are getting the indeterminate form is 0 by 0, 0 by infinity, infinity by infinity, etc. So in that case, you have to go with the different three methodologies. That is what I am going to teach you. So either you can go with the definition method, that is what we have found, left hand limit and right hand limit, and that in that way you can find. Otherwise, method 2, that is left hand limit and right hand limit. So limit x tends to 2 minus f of x is equal to limit h tends to 0 f of 2 minus h. Limit h tends to 0 2 minus h the whole square minus 4 divided by 2 minus h minus 2. So it will be limit h tends to 0 4 plus h square minus 4h minus 4 divided by minus h, right? And this 4 minus 4 and plus 4 will get cancelled. So this h is a common factor in the numerator, limit h tends to 0. If you take h outside, it will be h minus 4 divided by minus h. So this h and h will get cancelled. So in the numerator, there is a minus 4 if you h tends to 0. and denominator there is a minus 1, that will be plus 4. Look at that. When this h tends to 0, this term will be 0. You will get minus 4 by minus 1. So minus 4 by minus 1 will be 4. Similarly, limit x tends to 2 plus f of x is equal to limit h tends to 0 f of 2 plus h, that is limit h tends to 0 2 plus h minus 4 divided by 2 plus h minus 2 the whole square, which is equal to limit h tends to 0 4 plus h square plus 4h minus 4 divided by 2 minus 2 will get cancelled, there will be h alone. So plus 4 plus h will get cancelled. If you take h as a common factor, that will be h plus 4 divided by h. So this h and this h will get cancelled. H tends to 0 will gives you 4. So limit x tends to 2, f of x is equal to 4. So this right hand limit and left hand limit method is the common one. So whatever the problem, you can proceed in that way. Okay. We'll move to the next methodology. Factorization. Factorization. So our problem is limit x tends to 2 f of x, that is limit x tends to 2 x square minus 4 divided by x minus 2, that is limit x tends to 2 x square minus 4 can be written as x square minus 2 square, that is a square minus b square. This can be written as x plus 2 into x minus 2, because a square minus b square is a plus b into a minus b. So I can write this as x minus 2 into x plus 2, and the denominator will be x minus 2. So this negative will get cancelled. You will get limit x tends to 2 x plus 2. If your x tends to 2, you will get put x is equal to 2, you will get 4. You will get the same answer. So this is the method of factorization. This will work only if you know the algebraic formulas. So we'll move to the next and last method if you are getting the indeterminate form, that is L'Hopital rule or L'Hospital rule. So what is this limit rule? It is so simple if you know the differentiation. Okay. So limit x tends to 2 f of x is equal to limit x tends to 2 x square minus 4 divided by x minus 2. What you are going to do is you have to differentiate the numerator separately and differentiate the denominator separately. If you do differentiate until you are getting the indeterminate form get cancelled. Okay. So what you are going to do is you have to differentiate the numerator and the differentiate the denominator separately and tend the limits. So if it is till you are getting the determinant form, you are going to do this process. So if I am differentiating the numerator, what I'll get is 2x. If I differentiate the denominator, what I'm getting is 1. Okay, because this constant will get 0. So put x is equal to 2. So it will be 2 into 2, 4. This is so simple. So L'Hopital rule is it's based on this differentiation. You are going to differentiate the numerator and denominator till you are getting the determinant form of a solution. Okay, we'll move to the next methodology, that is rationalization. Look at this problem. It is little bit tricky because it has some square root within it. So suppose I am substituting the limit in this. In the numerator it will be 1 minus square root of 1 minus 0. 1 minus 0 will be 1. Again it will be square root of 1. So square root of 1 will be 1. So 1 minus 1 in the numerator it is 0. In denominator is also 0. So you will get indeterminate form. Right? Solution. Limit x tends to 0. 1 minus square root of 1 minus x square divided by x square. So it will be 1 minus square root of 1 minus 0 divided by 0. This is 1 minus square root of 1 divided by 0. 1 minus 1 divided by 0. So 0 by 0, right? So it is indeterminate form. So it is indeterminate form. We already learnt either we have to go with right hand limit or left hand limit, or otherwise we have to go with rationalization or factorization. So rationalization we do when there is a square root. Okay. So there is a square root in the numerator. So I am going to take a conjugate and multiply both the numerator and denominator so that I will remove the square root and I will find the solution. So limit x tends to 0, 1 minus square root of 1 minus x square divided by x square into square root of, excuse me, 1 plus square root of 1 minus x square divided by 1 plus square root of 1 minus x square. So it is a minus b into a plus b. So limit x tends to 0, a plus b into a minus b is a square minus b square divided by x square into 1 plus square root of 1 minus x square. See that this is my a and this is my b. So a square, 1 square will be 1 alone, and b square, so when I square the square root, that will get cancelled. So which is equal to limit x tends to 0, 1 minus 1 and plus x square divided by x square into 1 plus square root of 1 minus x square. This plus and negative will get cancelled, and so it will be x square divided by x square into 1 plus square root of 1 minus x square. So this x square and x square will get cancelled. Limit x tends to 0 and put limit x tends to 0, so that will gives you 1 by 1 plus square root of 1 minus 0, 1 by 1 plus square root of 1, 1 by 1 plus 1. So final answer will be 1 by 2. So limit of this function is 1 by 2. Okay. We'll move to the next problem. Infinite limit. So for infinite limit, you must take the common factors of the function just outside, because we know that if you put n equal to infinity, then 1 by infinity, 1 by n equal to 0. So we are going to use this concept here. So whenever there is limit n tends to infinity, okay, limit n tends to infinity, what we are going to do is, we are going to take the highest power of the element. If it is n tends to infinity, then you have to take the highest power of n outside. If it is x tends to infinity, then you have to take the highest power of x outside. In similar way, you are going to do plus 5 divided by minus 5n square plus 7n plus 9, which is equal to limit n tends to infinity. I am taking n square outside, so it will be 2 plus 3 by n plus 5 by n square. Am I right? So you can multiply with this n square. You can check whether we are getting the same term. And denominator also, it is minus 5 plus 7 by n plus 9 by n square. Okay. So the numerator n square and denominator n square will get cancelled. If the limit n tends to infinity, this term and this term will be 0, because 1 by infinity is 0. 1 by infinity square is also infinity, that is also 0. Similarly, this term will be 0, so you will get 2 by minus 5, right? Because 3 by n is equal to 3 by infinity, that is 0. 5 by n square is equal to 5 by infinity square, that is 5 by infinity, it will be 0, because 1 by infinity is 0, right? So whatever number you are multiplying, again it will be 0. Similarly, in the denominator, it will be 7 by infinity is 0, okay, and 9 by n square infinity square, that is also 0. You are getting 2 by minus 5. So hope you understand the concept of limit and its application, and how you can solve the problems based on limits by using the factorization method and right hand limit, left hand limit method, and L'Hopital rule, rationalization, and for indefinite method. So in the next video lecture, I will see you in a different topic. Okay. Thank you.